Rightio, g'day Year 12 Maths Unit 1 and Topic 1. This is your first lesson, and we're looking at association between categorical variables today. So the point of the lesson is that you first of all should be able to define bivariate data, then construct two-way frequency tables and determine the associated row and column sums and percentages. And then use an appropriately percentage two-way frequency table to identify patterns that suggest the presence of an association. Then understand an association in terms of differences observed in percentages across categories in a systematic, concise manner, and interpret this data in the context of the data. And finally, you should be able to solve practical problems by identifying, analysing and describing associations between two categorical variables or two numerical variables, and we'll do the numerical ones tomorrow. First of all, bivariate data is data that comes in pairs. Now you can analyse this bivariate data for a relationship between them, and we store a lot of this data in a two-way frequency table. So a two-way frequency table is used for displaying the two-way frequency distribution that arises when a group of individuals or objects are categorized according to two criteria. So we've got a two-way table here, and it's storing a bunch of information. We've grouped our data according to a male and female categories, and we've looked at the different types of the favourite tuck shop purchase for both males and females. What I have done though is put in some marginal totals. So a margin, remember, is something on the side of your page. So you'll be able to remember then that a margin here, in this case, is going to be a column total down here in this margin. And then we've got row totals in this margin. And then we've got a grand total there. Now to get our totals, I'm just adding across for the row totals. So 23 and 14 make 37, 12 and 19 make 31, and so on. For our column totals, I am adding down. So I have a column total there for the margin for males. So you can see that, well, I've got a lot more males surveyed here than females. And then to get the grand total, I can either sum down or sum across, and both these numbers should be the same. So that's a handy way to check. Now we can convert this into a percentage. So to convert each of these to a percentage, what we want to do is just read across in this case. So for example, to look at the males that prefer chocolate milk, so I'm just going to go 23 over, in this case, 160, so 14% of the students is a male that prefers chocolate milk. What else do we need to consider? If we want to do another one, let's just say 8 out of 160 then. So females that prefer chips as their favourite, all you do is you go 8 over the total over 160 times 100%, and then you can work that out. What else do we want to have a look at? So we've just now created a table with some percentages in them, but we've got a problem here that we've got an unequal distribution of males and females. So what we can do is make it easier to compare the two, and what we're going to do is just do a proportion then of the males compared to the females. So we're just going to sum down, so do the column totals there, and if we have a look at the males that prefer chocolate milk, in this case it's going to be 23 over 94. So there's our 23, there's our total 94, then times it by 100 to get our 24%. So that's it there. So likewise, if I want to go somewhere random, so if I want to go chicken burgers, girls that prefer chicken burgers, so it's 16 over 160, and so whoops, sorry, 16 over 66, So, and then it's just times 100 to get our 24%. Now, an association is a general term that's used to describe the relationship between two or more variables. And now it's often used interchangeably with correlation. However, it's important to know that association does not imply causation. So there's a bunch of different interesting relationships you can go there, and there's an interesting website called Spurious Correlations, and you can find a few good ones. So, for example, here's a correlation between autism and organic food sales, and they imply that as one goes up, so does the other. However, it's very doubtful that the increase in organic food sales increases or causes an increase in autism. So we have to be careful about the data that we're analysing for an association. And finally, we should just talk about a causal relationship, is that it's a relationship between the explanatory variable and the response variable. And it's a response variable is said to be causal if the change in the explanatory variable causes a change in the response variable. Now, if we want to describe an association, we first of all going to analyse some. So we've got to decide on the variable that may have influence over another. So we've got genders and favourite colour here. So we've going to then calculate the percentages of the variable with the influence. Then we'll describe the association in terms of differences in the percentages across the categories, and then interpret the observations in the context of the data. So what do we got here? We've got 18 and 21, so we've got 39 students here surveyed for their favourite colour. What we want to do first of all is just calculate the percentage, and we're going to, for example, to look at the males that prefer blue, so we just go 12 over 18, then times by 100. So we can say, well, 67% of the males' favourite colour would be blue, as opposed to 33% of the females would prefer blue over purple. And then you can just analyse, and we can make a couple of conclusions over here. So we can say that 67% of the males prefer blue compared to 33% females. And likewise down below we can say 86% of the females prefer purple compared to 14% males. So we've done a little bit today. So can you define bivariate data? Remember that comes in pairs. And then construct two-way tables. Calculate those marginal totals across the rows and the columns, and then convert them into percentages. Can you use appropriately percentage two-way tables to identify patterns and suggest the presence of an association? Can you understand that an association in terms of differences in percentages across the categories in a systematic and concise manner, and interpret that in the context of the data and then solve problems relating to that? When you're confident with this, I'd like you to work on the mastery exercises from your textbook there, please.